Hi everyone, welcome back. As you know, this is the lecture portion of AP Psychology. This is where I'll go over the content of each module of a particular unit. In this case, Unit 1, Module 4, which is Research Methods. Go ahead and pause for a moment, grab a pen, grab a seat, and don't forget to grab your notes on today's section of notes in your binder called Unit 1, Module 4, Research Methods. I'll see you on the other side. Okay, so in this set of notes, our learning targets, well, there's really just one big one, and that is research methods, knowing the difference between them and the benefits of each, whether that be experiments, correlational studies, survey research, naturalistic observations, case studies, longitudinal studies, or my personal favorite, cross-sectional studies. It's a lot. Okay, let's get started. The first big concept that we need to go over about research is correlation. I want you to notice that there's two root words here. There's co, and there's relations. So co-relations equals correlations. It's when there's a relationship between two variables and that relationship can go both ways, right? Now stay tuned because we are going to talk way more about this, so much more. But that does not mean that one causes the other. It just means that they are correlated, that they are in a relationship with one another, and therefore they have an influence on one another. Now, make sure you get that, even if you need to rewind here or pause. I'm going to say it again. Make sure you write it down. Two variables that have a relationship or an influence on one another. Now, there's two directions that they can go in, right? They could rise together or they could fall together, right? Increase or decrease together. Variable 1, variable 2. When there are two variables that increase together and they decrease together, we call it a positive correlation. Now I want you to hang on to this next tip, but I'm going to tell you because we'll talk about it in our learning unit and later on, really in all of our different units. So, positive in psychology, 90% of the time does not mean good. It's not that it doesn't mean good, but I'm going to say it again. Positive does not mean good. It means adding something, or in this case, it means going upwards on a scale. And if there's a positive slope, so hang on to that for a second. We're going to talk about what that means in just a moment. An example of a positive correlation is where two variables increase or decrease together. Let's take, for example, the number of gallons of gas pumped. So as gas is pumped, it rises. It's positively correlated to the amount of dollars or money spent on gas. So the more gas you pump, the more you spend on gas. However, you could also say that the less you spend on gas, the less gas that you have pumped, right? So they either rise together or they fall together. And that makes it a positive correlation because they go in the same direction. Now, a negative correlation does not mean that it's bad, just like positive doesn't mean that it's good. Negative and positive in psychological research does not mean bad or good. Negative simply means that when two variables are moving in opposite directions to one another. And I very much encourage you when you're looking at scenarios in class and tests and quizzes and whatever, but that you use your fingers when you are on a quiz question or a test question and you see, for instance, the number of gallons of gas pumped positively correlated with the amount of money spent on gas. Okay, I'm going to draw a little arrow above the gallons of gas, okay? And that goes up when the other one goes up, or that goes down when the other one goes down. So either use arrows on your paper or use your fingers. It's just really super helpful. When they're both doing the same thing, it's positive slope. So with negative correlation, two variables move in opposite directions, right? One goes down, one goes up. An example of this being miles traveled is negatively correlated to the amount of gas left in your tank, right? So that the more miles you travel, right, you're traveling and the numbers are going up on your odometer, but the gas gauge is going down, right? So you could say the more gas you have in your car, the less miles you have traveled. But what makes it negative is the fact that they're going in opposite directions. Okay, slide number 4. Correlation strength is another thing you want to think about when looking at the relationship of two variables. When it comes to strength, when there's a strong correlation, it's easier to predict. For example, as the number of gallons of gas are pumped increases, so too does the amount of money you spent on gas. With a weak correlation, we get less predictive variables. For example, as the color of a car gets darker, the more gas the car uses. Just using common sense here, we can see the difference between a strong and a weak correlation. That did not have anything to do with the other, right? Color of car and amount of gas used, no correlation, no relationship. All right, so let's take a look at the next thing, which is called scatter plots. Scatter plots are a graph that comprise of points generated by the values of two different variables. A scatter plot is a graphic representation of a correlation. I want you to write that down. If you need to pause and rewind, go ahead and do that. A scatter plot is a graphic representation of a correlation of two variables. So it's a correlation on a graph. That's all. So the slope of the points depict the direction. Again, the slope of the points, the line of best fit, shows you the direction, and the amount of scatter shows you the strength of the relationship. So the slope of points depicts the direction. Again, the slope of the points tell you the line of best fit. It shows you the direction. So over here, you see, it starts out low and it builds up, 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 up. So that's a positive, perfect correlation. This means you'll see as you go up, each number is in a straight line. That's a perfect positive correlation. Okay, we're going to talk about this little number here, positive 1.0, in a few minutes. But for now, you should notice that this would be a perfect correlation. Whatever this is on this axis and this is, they have a close relationship. Okay, it's not often that we see something like this in the real world. A perfect correlation does not occur that often. Where this one is a perfect negative correlation, right? It starts out high and it drops down, drops down, drops down in a straight line of best fit. So it's a perfect negative correlation. Right? Remember, positive and negative doesn't mean good or bad or bigger or smaller. It just means the direction of the slope. Now this third one over here is what we call a scatter plot, right? You can see the scatter. The data points are all over the place. There's a little bit of a downward trend here, but a bunch of outliers all over the place. So the more spread apart the data points are, the Y's and the X's all over the place, the further apart the relationship. Okay? The further apart the relationship between the two variables. So, what you need to take away from this visually is that the direction of the slope indicates positive or negative relationship of the correlation. And then 2, the amount of scatter, or how the data points scatter on the scatter plot, indicates how strong the connection is, the relationship. So the more you can find that line of tight best fit, the stronger the relationship. The more it's spread apart, the worse the relationship. Okay? Now, let's talk about the correlation coefficient. The correlation coefficient is the number that you saw back here next to each graph. +1, -1, and 0. Okay? The positive or -1 or even the 0 are all super important because your variables will always be between the two numbers of -1 and +1. Again, this is going to fall where the correlation coefficient would be. So it's the statistical measure that shows the degree of the relationship between the two variables. In other words, it's just a number that shows you the correlation, the relationship, whether it's an upward or a downward direction, and the strength or the closeness and tightness of that line. So whatever the R equals, right? Whatever the R equals indicates the direction and the strength of the correlation. Okay, so here we have R equals plus positive 0.37. I want you to cover up one thing at a time. If you put your hand over that 0.37, what do you have left? A positive sign. That just tells you the direction. When you just cover the positive, you have a 0.37. Right? I want you to think of them as separately when you first start looking at correlation coefficients. I want you to cover up one or the other when you're looking at it. So what I recommend you do is cover up this number and figure out what it means. So you're looking at 0.37 positive. So you're on the right side, right? The right side of a number line. Okay, imagine that it starts at 0 and it goes up to 1. The closer it is to 1, the tighter the relationship. So between 0 and 1 on the positive side, we have 0.1, 0.2, 0.3, 0.4, 0.5 is halfway. Here we're at 0.37, right in between that halfway mark. And then after 5, 6, positive 7, 0.8, 0.9, 0.10. Okay? Same thing with the negative, only you're working with the negative. So it's -0.1, -0.2, -0.3, -0.5, and so on. Okay? The coefficient will always fall between -1.00 and positive 1.00. Always. The closer the positive or negative to the 1, the stronger the relationship. The closer it is to 0, the weaker the relationship. Okay, so if we're looking at 0.037, we're saying it's on the positive side. It's a 0.3 out of a 0.10. So it's not quite halfway there. It's about a quarter of the way or a third of the way there. So we know that that is a sort of weak correlation. Okay? It's a weak correlation because it's 0.37. It's pretty far away from the 1.0. The 1. Okay, so the closer you are to the -1 on this side, the closer you are to the -1, the stronger the relationship. The closer you are to 0, the weaker the relationship. It doesn't matter which direction you're going in. Okay, let's take a look at a few examples, some coefficient examples, right? We're going to take a look at the number and then we're going to apply it to real life. So our first one we're going to look at, and we right away know if we cover the number, it's a positive. So we're dealing with this side of the number line, right? The positive side. But this is a positive 7, 8. That's a lot bigger, right? That's a lot closer to 1 than that 0.3 was. So that's going to be a very sort of strong, moderately strong, but positive correlation, right? And what could be a real world example of two variables with this kind of almost really close to 1.0? Okay, let me give you an example to start you out. It's pretty strong, right? It's a 0.78. That's almost a 0.10. So there's like not very many things that are this related when you're talking about variables in the real world. So we know that it's going to be a number that's close to 0.9 or 0.8, and this is just almost 0.8. So one example that could get you in the headspace of that would be just height and weight, right? Because a person's height goes up, the taller they get, the more they weigh. As the weight goes up, their weight goes up. As their height goes up, their weight goes up, I mean. Okay, so they're very closely connected, height and weight. That's why it's a 0.78. It's so close. The relationship is so close, it's almost completely close to 1. Okay, the next one is positive 0.05. That couldn't be less close to 1, right? It doesn't even make it to the 0.1. It's 0.05, right? So this is so close to 0 that it's only half a point up. Okay, so that's a very weak positive correlation. Positive because it's on the positive side of the number line. Very weak because it's so far away from 1.0 but so close to 0. Right? We would have to go to 0.05. We're halfway to 0.1. Then 0.2, then 0.3, 0.4, 0.5, you're halfway, right? This is 0.5, this is 0.05 on the number line. 0.6, 0.7, 0.8, 0.9, and then 1. Okay, so very weak positive. What could be an example? Well, maybe you want to convince your parents that your grades are not dropping because you're playing video games, right? The more you play video games, the less you're doing well on your test. Your test grades are falling, right? So you would want to find a study that says the more that you play video games, there's no evidence of any grades going down. So you would want them to be so loosely correlated they have nothing to do with each other, right? Because 0.5 is much closer to 0 than, say, 0.95, which would totally disprove your argument and be close to, 1. All right, let's look at the next one. Negative 0.43. Negative 0.43. Okay, so cover the number. What direction are we going in? Downward slope, negative. But it's a moderately weak, right? It's moderately weak. It's almost at the halfway point to -1, right? So it's, if we were on the number line here, just imagine a number line. We're at 0, right? We're going to -1 all the way over here. So we need -1, -2, -3, -4. 0.-5. We're right there between 4 and 5, the halfway mark. So you're halfway to being close to number 1 and halfway to being close to 0. Somewhere right about in the middle. Okay, that said, what would be a real world correlation for 0.43? Okay, let me help you out here. Let's say that a guy is dating a girl and his parents are concerned that his grades on his tests, his scores are going down because he's hanging out with his girlfriend too often. The more he hangs out with her, the more his grades go down, right? So there's a moderately weak correlation, meaning there could be a million different reasons why his grade is going down. It doesn't necessarily have to do with his girlfriend. Okay, that's why it's 0.43. So that would be a hard one to get to prove to the kid that there's a relationship there. The relationship is moderately weak. Okay, the one is going up, one is going down. That's what makes it a negative. But the weakness is because there's lots of other reasons that somebody does poorly on an exam. Okay? Is negative 0.92. Negative 0.92. That's right off the bat. When there's a 0.9, you know it's super strong. The fact that it's on the negative side of the number line doesn't make a difference. It's super close to 1.0, right? If we're 10, 20, 30, 40, 50, 60, 70, 80, 90, 1.0, all the way down there. So even though it's negative, it's super strong, right? A very strong negative slope. What could be an example for a correlation coefficient of negative 0.92? Here is one for you. The more time that you study or prepare for a test, the fewer questions that you'll get wrong. You see that? The more time you study, the fewer questions you'll get wrong. It's negative, but it's a strong correlation between the two variables, right? It's a good thing that you're studying. Right? There's a 0.92 relationship. That's a strong relationship. So close to 1. All right. Here's another example of a scatter plot. All right, let's look at this. What we've got here is on this axis, we have temperament scores. And down here, we have height in inches. Okay, so temperament does have to do with your temper, but it's really about your emotional reactivity to life. Like, are you kind of high-strung and, like, blowing up all the time? Or are you kind of easygoing and chill and even and mellow, right? Temperament is super visible in all humans and noticeable. Even in infants, we can tell when they're cranky and right? So height in inches and temperament. Let me ask you this. How closely is your height related to your temperament? Not really at all, right? Both short and tall people can be angry or aggressive or assertive or cranky all the time. Short and tall people could be super mellow and groovy all the time too. They don't really have a lot to do with each other. But look at this graph. We see that there's a lot of scatter, but there's an upward slope, right? It's kind of going up. It's a little all over the place, but it's kind of going up. The line of best fit would be upward, which that means even though it's scattered, we know it's a positive, right? It's a positive coefficient. You could probably guess just by looking at the scatter that it's somewhere around a 0.5 or a 0.6 out of 1, between 0 and 1 on the positive side of the timeline, right? Because it's not tight, it's not a straight, perfect line. It's about halfway there. right? It goes upward. We can clearly see if we connected these right here, straight up, but we have these, they're not all the way over here or all the way over here. They're pretty close to the line of best fit. So about halfway there gives us a nice correlation, right? It shows the temperament and relationship might not be related closely, but there is some evidence that there's some kind of a trend going on there. It's moderately positive, and it comes out to actually a 0.63. Okay, a 0.63 out of 1. Alrighty, now we're going to talk about correlation and causation. Just because two variables have a relationship, just because they're together, doesn't mean that this one causes this one, right? Knowing two variables are correlated does not necessarily tell us how or why they're related, right? Just because this one and this one have something to do with each other and they hang out together and they have a relationship, one behavior doesn't affect another behavior necessarily. One might be correlated, there's a connection, but it doesn't mean cause and effect, or this one caused that one. Here's an example. Low self-esteem and depression, right? We know that low self-esteem comes from a variety of different things, not just depression. Does depression cause low self-esteem? Yes. But also, low self-esteem can cause depression. Depression can cause low self-esteem, and low self-esteem can cause depression. There's lots of other things that could cause depression and lots of other things that could cause low self-esteem. Okay, a distressing event, for example. Somebody dies in your family, you're going to have you could possibly have a major depressive episode. Right, it makes sense. There's a good reason for it, but it doesn't mean that it caused the other thing. Right? There's lots of things that can cause both of these things. Now, when you get questions on the AP test, they're going to try to trick you on the College Board. They're going to say something like, here's one variable and here's another variable. How did this variable cause something in this variable? And you're going to say, low self-esteem cannot cause depression. Depression cannot cause low self-esteem only. There's lots of different reasons. So I'm going to mark that question choice out. Right? Just get rid of anything that says one thing causes another. Because the only time that something can be measured like that is when you do an experiment. The more you do an experiment, the more you can talk about trying to see what causes what. All right? So we're going to kind of put correlation and causation on hold for a few minutes. And we're going to talk a little bit now about the 3 types of research. Okay, this is about research, so let's get a little bit more about that going on. Descriptive observational research is simply when somebody observes and records their behavior. Okay, records, and you might just like watch your subject, how they act on the playground, or if you're a child psychologist, how they act when they're playing with their little friends, how they act when they're alone, how do they act in the classroom, and you just simply take notes as you observe your subject. Correlation, the second one, is finding a relationship between the 2 variables. We just spent the last 15 minutes doing that. And experimental research is when you actually have a controlled setting where you can manipulate the variables to see if one causes something in the other. Okay, that's the only one, the third one, experimental, that even comes close to causation. Okay, we're going to talk a little bit about Jane Goodall. Okay, Jane Goodall is an example of a naturalistic observationist. She observed human or animal behaviors in the environment in which it typically occurs. That's a definition. Her subject was gorillas, or different types of gorillas and chimpanzees and stuff like that. She is best known for going into the jungle and living amongst them and just watching what they did in their natural setting. Right? So I'm going to have you listen to this little YouTube video.
Louis Leakey sent me to Gombe because he believed that an understanding of chimpanzees in the wild would help him to better guess how our Stone Age ancestors may have behaved. It had long been thought that we were the only creatures on Earth that used and made tools. Man the toolmaker is how we were defined. And here was David Greybeard using a tool. It was hard for me to believe what I'd seen. A few days later, I watched, spellbound, as chimps set off to a termite mound, picked a small leafy twig, then stripped it of its leaves. That was object modification, the crude beginning of tool making. It had never been seen before. When I telegrammed the news to Louis Leakey, he responded that we must now redefine man or accept chimpanzees as human. My observations at Gombe would challenge human uniqueness, and whenever that happens, there is always a violent uproar. There were some who would try to discredit my observations because I was a young, untrained girl and should therefore be disregarded. The result of it all, however, was that Louis was able to obtain a grant from the National Geographic Society to continue my study. In addition, they would be sending out a photographer to document the chimpanzees.
Okay, so just to be clear, it's valuable to know that naturalistic observation were valuable where other methods are likely to be disruptive or misleading. Okay, there are some problems, though, with naturalistic observation. If people know that they're being observed, they tend to act differently. Right? They act differently when they know they're being filmed or watched. This is called the Hawthorne effect. I would make sure you write that one down. And when people know they're being observed, they definitely act a little bit differently. Now, ethically, you have to usually tell people that you're observing them, or that they're part of an experiment, or they're part of a research project. So you then have to combat that by observing them for a really long period of time. And then how do you know if their behaviors are actually natural? And observations can be distorted if the observers approach the situation to see certain behaviors, right? They have that bias where they're looking for that behavior to fulfill their research. And if they see it, they kind of blow it up in their mind and in their research and kind of pretend that the other stuff that they didn't want to know was part of it is actually also there too. So you leave out the parts that you don't want in your research, you put in and make really big the parts that you're looking for. That's one of the pitfalls of using natural observation as a psychological technique. Okay, next up we have a case study. Case studies are really important in psychology. We're going to watch a quick video clip, so go ahead and take notes on the video as we are watching it. Feel free to pause and make sure you get everything that you need for the case of HM.
On September 1st, 1953, William Scoville used a hand crank and a cheap drill saw to bore into a young man's skull, cutting away vital pieces of his brain and sucking them out through a metal tube. But this wasn't a scene from a horror film or a gruesome police report. Dr. Scoville was one of the most renowned neurosurgeons of his time, and the young man was Henry Molaison, the famous patient known as HM, whose case provided amazing insights into how our brains work. As a boy, Henry had cracked his skull in an accident and soon began having seizures, blacking out, and losing control of bodily functions. After enduring years of frequent episodes and even dropping out of high school, the desperate young man had turned to Dr. Scoville, a daredevil known for risky surgeries. Partial lobotomies had been used for decades to treat mental patients, based on the notion that mental functions were strictly localized to corresponding brain areas. Having successfully used them to reduce seizures in psychotics, Scoville decided to remove HM's hippocampus, a part of the limbic system that was associated with emotion, but whose function was unknown. At first glance, the operation had succeeded. HM's seizures virtually disappeared, with no change in personality, and his IQ even improved. But there was one problem. His memory was shot. Besides losing most of his memories from the previous decade, HM was unable to form new ones, forgetting what day it was, repeating comments, and even eating multiple meals in a row. When Scoville informed another expert, Wilder Penfield, of the results, he sent a PhD student named Brenda Milner to study HM at his parents' home, where he now spent his days doing odd chores and watching classic movies for the first time, over and over. What she discovered through a series of tests and interviews didn't just contribute greatly to the study of memory, it redefined what memory even meant. One of Milner's findings shed light on the obvious fact that although HM couldn't form new memories, he still retained information long enough from moment to moment to finish a sentence or find the bathroom. When Milner gave him a random number, he managed to remember it for 15 minutes by repeating it to himself constantly. But only 5 minutes later, he forgot the test had even taken place. Neuroscientists had thought of memory as monolithic, all of it essentially the same, and stored throughout the brain. Milner's results were not only the first clue for the now familiar distinction between short-term and long-term memory, but showed that each uses different brain regions. We now know that memory formation involves several steps. After immediate sensory data is temporarily transcribed by neurons in the cortex, it travels to the hippocampus, where special proteins work to strengthen the cortical synaptic connections. If the experience was strong enough, or we recall it periodically in the first few days, the hippocampus then transfers the memory back to the cortex for permanent storage. HM's mind could form the initial impressions, but without a hippocampus to perform this memory consolidation, they eroded like messages scrawled in sand. But this was not the only memory distinction Milner found. In a now famous experiment, she asked HM to trace a third star in the narrow space between the outlines of two concentric ones, while he could only see his paper and pencil through a mirror. Like anyone else performing such an awkward task for the first time, he did horribly. But surprisingly, he improved over repeated trials, even though he had no memory of previous attempts. His unconscious motor centers remembered what the conscious mind had forgotten. What Milner had discovered was that the declarative memory of names, dates, and facts is different from the procedural memory of riding a bicycle or signing your name. And we now know that procedural memory relies more on the basal ganglia and cerebellum, structures that were intact in HM's brain. This distinction between knowing that and knowing how has underpinned all memory research since. HM died at the age of 82 after a mostly peaceful life in a nursing home. Over the years, he had been examined by more than 100 neuroscientists, making his the most studied mind in history. Upon his death, his brain was preserved and scanned before being cut into over 2,000 individual slices and photographed to form a digital map down to the level of individual neurons, all in a live broadcast watched by 400,000 people. Though H.M. spent most of his life forgetting things, he and his contributions to our understanding of memory will be remembered for generations to come.
Okay, so as you saw with the H.M. case, a case study is, by definition, an intensive examination of the behavior and mental processes associated with the specific person or situation. Some of the benefits of a psychology case study could be it allows for an in-depth investigation into a person, group, or event. It does allow some generalization by taking the information from that one case to apply it to the bigger world, even though that's not something you could usually do in psychology. When something is stumbled upon with a case study and you can't get the information any other way, you can apply the generalized information to other research studies or to the general population. It also lets researchers examine something that would be impossible to conduct via experiment, right? The fact that there is only probably one person or a couple of people in a small group, it lacks the ability to treat as you might a wider study with multiple people from various groups. For example of this was called Patient HM to protect his identity, but he had a brain surgery that removed part of his temporal lobe, and I think they may have even removed part of his hippocampus. And so they just kind of wanted to observe him and see what would happen, because you can't just go and find some Joe Schmo on the street somewhere and ask him to say, hey, let's go do some brain surgery and see if we move some of the chunks of your brain out and your temporal lobe, what will you act like? Right? That would be incredibly unethical and really just ridiculous. But when it happens out of sheer surprise, or you stumble upon somebody who is medically out of the norm with some medical necessity, and you want to observe and do a case study on that particular person, it might also be an opportunity to see what the effects are for a particular thing. That would be an opportunity to do a study on something where you normally wouldn't have a sampling of group of people. So, in general, you have to be very careful, and the biggest problem with case studies is to make sure you write this part down now. The biggest trouble with case studies is you can't generalize, and it's called generalizing. Right? You can't generalize just because you have one small group of people or a person and say that that might happen to the population. You can't say that it will or won't happen to even one or a few or 10 people, because when you do a psychological experiment, the assumption is you are doing a wide study, right, with hundreds or dozens of samples. But again, if you stumble upon a special opportunity that arises and you take advantage of it, it could provide valuable material for further research, right? It will get the ball rolling. It serves as a testing ground for new treatment training programs and other applications that are really important for research. Okay, so next up is the survey. Okay? Survey is our next method that we're going to talk about in terms of techniques for ascertaining those self-reported attitudes. Okay? Self-reported attitudes, opinions, or behaviors of people. This is usually done through a series of questioning, right? Right? You get together with a research team and you come up with a series of questions that are representative and random sample of people. You know what a survey is. You answer the questions and then it can be used part of the operational definition within your study, right? So if I'm doing, let's say, an experiment on how, I don't know, the color of socks, let's say the color of socks impacts happiness. And I'm measuring how happy a person gets when they wear a particular color of socks. Well, guess what? Happiness is an attitude, right? It's a concept. It's not something that you can measure with a ruler. It's a feeling, and really the only real way to assess it is through self-reporting, right? You have to ask somebody which color socks makes them happiest. And so my operational definition within my experiment of my dependent variable would be to be using a survey, okay? Validity of data depends upon a few things here when it comes to taking a survey, okay? It's all about how the questions are worded. You have to be extremely precise in making sure that your questions are not ambiguous or that they are not leading. Leading is when you lead people to answer it in a certain way because the whole thing is just botched then. But also then you want a representativeness of people surveyed, and you can't just interview, right? You can't just interview or survey a few particular people and then say that this applies to everyone in the world, because it doesn't, right? It doesn't apply to everyone. You didn't include all types of people from all cultures, all ethnicities, all generations, all sexual identities, all genders, right? You didn't include all people from all different countries, all different religions, all different backgrounds. You didn't include all types of people with other limitations that would be the willingness of people to honestly participate in that survey and complete it. Not just do a few and people may say what they believe they should say, right? That's one of the problems too. Right? People want to either say what they think that they should be saying or answering to please the questioner or the researcher, or they want to be an outlier and they want to be different or special, or they want to be a critical thinker and really represent as somebody that's really extra smart. So they might answer in a way that isn't actually true. It's still a great way to gather large amounts of information in a really effective and efficient way. It's not expensive, and you can get lots of data from just a few questions. All right, so the last thing that we're going to talk about is what is called a quasi-experiment. So in our next set of notes, we're going to talk about what an experiment is, but in this one, we are going to talk about just the quasi-experiment. Quasi-experiments are studies that have the same control as experiments, yet do not include random assignment of participants. Right? So that may not make a ton of sense for you right now, but it will when you take the experimental notes. So let me kind of bring it back a little bit and simplify it for you. Quasi meaning almost fake. It's like an almost fake research, an almost real research. And the reason why they have to do fake research as part of their study is because it would be unethical to do it for real. So, For example, researchers might want to test, I don't know, the hypothesis that a pregnant woman's use of psychoactive drugs will cause abnormalities to her developing fetus in the baby. Now, we talked about this a little before, right? And the problem of not being able to go out and get a million or even dozens of participants for your survey. And that's exactly what this is.
A quasi-experiment is designed a lot like a true experiment, except that in the quasi-experimental design, the participants are not randomly assigned to experimental groups. In a true experiment, research participants have an equal chance of being assigned to any condition of the independent variable, the one being manipulated by the researcher, that is involved in the study. So, for instance, if a researcher was examining the effects of caffeine on reading comprehension, she might randomly assign participants to one of 3 independent variable conditions: those who drink 1 cup of soda, 2 cups of soda, or no soda. She might then assess each person's reading comprehension abilities following exposure to the independent variable. In a true experiment, each participant who volunteered would have an equal chance of being assigned to any of the 3 groups. Quasi-experiments are employed when the researcher is interested in independent variables that cannot be randomly assigned. Usually, this happens when the independent variable in question is something that is an innate characteristic of the participants involved. Let's look at a couple of examples to help illustrate the point. Here are 2 examples of simple quasi-experimental designs that will help you see the difference between a true experiment and a quasi-experiment. Dr. Jones is a personality expert who studies the impact that personality traits have on intelligence. For the purposes of her current research project, she is interested in examining the IQ scores of people who score highly in each of the big five personality factors. Each of the 5 personality factors are a quasi-independent variable. Personality traits are inherent to each person, so random assignment cannot be used. Participants would initially be assigned to groups based on their personality assessment score across each of the 5 personality factors. Now that Dr. Jones has her participant group assignments, she can examine the impact that personality factors may have on intelligence. If a true experimental design were used, each participant would be randomly assigned to each personality group regardless of whether or not they possess those personality traits, which would not really address the question that Dr. Jones is asking. Let's look at one more example. Dr. Lloyd is a multicultural expert and is interested in the effect that race has on academic dishonesty. People cannot be randomly assigned to different race categories, so a quasi-experimental design is used. If she is interested in examining academic dishonesty among Caucasian, African American, and Native American college students, then as participants volunteered for her study, they would be assigned to the appropriate group based on their self-identified race. Once the groups have been assigned, Dr. Lloyd can expose each group to the measure of academic dishonesty that she created and evaluate the results to see if differences emerge between the groups. As with all experimental designs, there are advantages and disadvantages. The inherent advantage of the quasi-experimental design is that the participants can easily be assigned to groups controlled by the experimenter. This is particularly useful when you want to examine characteristics of people who possess certain innate qualities, such as personality traits and race. The disadvantage in using a quasi-experimental design is that internal validity, or the degree to which an observed relationship truly exists, is compromised. In a true experiment, random assignment helps to ensure that any observed relationship that seems to exist between independent variables is real. Recall that in quasi-experiment, the independent variables are not subject to true random assignment. So, just because the researcher assigns people based on race or personality traits, there could still be other unknown variables in play that are not controlled for. Random assignment helps to diminish the impact that those unknown factors may have on the results. Quasi-experimental designs do not rely on random assignment when placing participants into experimental groups. Quasi-experimental designs are used when the independent variable is such that random assignment cannot be used because it is related to some innate quality, such as race or gender. quasi-experimental designs are useful in that they allow researchers to study the impact of certain innate qualities on the people who possess them. But researchers also have to be reminded that internal validity, or the degree to which perceived relationships are real, is compromised.
Okay, so before we close, the final thing I want to say about a quasi-experiment is that the conclusions are not as firm as those that are drawn from true experiments, yet they do allow research to be conducted on topics and in settings that would otherwise be impossible. So there is a value to them. Okay, guys, I will see you all tomorrow. And finally, I think that this video is done for real. Night, night.